Okay, so if you could title your piece of paper 3 dash 8, yeah. 3-8 complex numbers. Essential question. What are the 2 parts of a complex number? And why do complex numbers exist? What are the 2 parts of a complex number? And why do complex numbers exist? Then, on one side of your paper, I give you all a large rectangle. Large enough for you to write things inside of it. Does that do prove a straight line? If you want to outline a straight line, you can use the edge of your calculator with. So I'm going to draw a straight line. Build the side on the right step on the left-hand side. Large enough that you can write things inside of it. Okay, I want you to think back to when you were like 2 years old. What are the first numbers you started to say when you were about 2 years old? 1, 2, 3, right? That's all I got. 3. Why were those the first numbers you started saying? The what? It's simple, and you have a reference. Reference. So I pay attention. Did you have a reference to the numbers 1, 2, and 3? Did you have the picture of 1, 2, and 3? Objects or Rachel? Fingers. Don't you have fingers? Don't you show you 1 and 2? They show you 1 and 3. They go through our eyes, and that's why I got 3. And then it goes into H's either. And on Sunday, when I was flying back, I ended up flying back from LA to go home to Utah from the soccer game. And going from high school and for the kids, so I went and watched her. And so she was introducing all the kids, and the robot is like, I'm 5. And she has to, little kids have to show you with their fingers, right? Like, I'm going to show you how old they are. Because it's something tangible that they have, and it's natural to them. Hence why the numbers starting with 1, 2, 3, 4, 5, etc. are called the natural numbers. The symbol or abbreviation for natural numbers is a capital N with a slash through it. That is the natural numbers. The natural numbers is the sum of all numbers inside these squiggly braces. So if you have squiggly braces, it's showing you a set or a family of numbers. The smallest natural number is 1, and then it goes up 2, 3, 4, 5, blah, blah, blah. Meaning it goes all the way through positive infinity. Okay, what's the next number you learn about? 0. Also, you learn saying no, and then this is a 0, right? Just by adding 1 family of numbers. This family encompasses all of the natural numbers and has one extra element. The element is 0. Okay, don't talk about please. Raise your hand. You know what these numbers are called. What's the family called? Oh, not yet. You want to say what it's called? What does 0 look like? A whole. Isn't that a whole? Whole number, but it's going to W. Whole. So the abbreviation capital W with a slash to it, which is whole numbers. Okay, then we have what Rebecca just said. After 0, you start learning how to subtract, right? And you add and subtract. But specifically with subtraction, like 2 minus 5, you get a new number that's not in the family of numbers. What's 2 minus 5? -3. So we have in the negatives, what type of numbers are those? Integers. This is not an I. Integers is notated by capital V, the slash. So it's like the Canadian Z, we call those little Z. Integers, these are I and something else. Integers. Integers are the set of all counting numbers from positive, negative, and 0. So it doesn't start at 0, it actually starts with -3. So I'm going to start with dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. It goes on forever in both directions. As you get older, your number sense of the world keeps expanding. But that wasn't it, was it? Then you just where it stopped. Oh, then you guys multiply and then specifically divide. Does everything come out nicely when you divide? No, you get fractions or what else do you get? Decimals. What type of numbers are fractions and decimals? Specifically decimals that can be written as fractions. You know all of them. How do you two hold them up? You know them all. What about the rest of them? You know what they're called? Can you get a fraction? Together? Rational. Good job. Rational. And rational, there isn't an R, that's for something else. Rational divided into 2 is a capital Q. Rational. Okay, before I write down the three qualifications for rational, would you take your rectangle about 2/3 of the way over? So not in the middle, about 2/3 of the way over and divide it. Okay, now we're going to make a different diagram of how the numbers progress. First, we're going to about the natural numbers, right? Are all of the natural numbers contained within the whole numbers? Yeah, whole numbers has one more number. What is that one more number to have? 0. So the whole number encompasses all of the natural numbers, plus one more element, which is 0. So whole numbers should encircle around the natural numbers. What encircles around the whole numbers that encompasses all whole numbers plus more? Integers. So these are all encompassing the integers has whole numbers and natural numbers inside of it. Now, rational numbers, we said, has to be, there are three qualifications. I said that they have to be written as fractions. Could the natural number 4 be a fraction? 4 divided by 1. Agreed? What about the whole number 1? Could that be a fraction? 1 divided by 1? What about the integer -3? -3 divided by, it changes the value. So it has to be divided by 1 to not change the value. So all of the natural forms of integers can all also be written as fractions. So rational encompasses all of our natural whole integers and more. This is also encompassed besides all of these integers that came as fractions. So I don't have to go yet. I know these words over here. You know the last one. Here's L. Ln. Decimal. Do you know what type of decimal is? You don't know what type of decimal is? I don't know here. So we're going to take the next one. What are decimals? What's the difference between written as fractions? Terminating decimals. Thank you. Terminating decimals. Terminating decimals such as 2.4. That's not an integer, but then the decimal that terminates. And that 2.4 can be written as a fraction. What are some ways to write this as a fraction? Means ends, yeah. The little one forever terminator, like the terminator, what's his name? Okay, I don't switch name, I think you, I actually know his names, but he like terminates stuff, ends, it ends. 2.4. What place value is that 4 in? Tenths, because 10 is 1 0, so it's 1 position over. Hundredths has 2 zeros, so it's 2 positions over. Okay, so we can write this as a fraction, 2 and 4 tenths. As it's not simplified form, you just simplify it and write another fraction which has the same value, but it's proof right there you can write as a fraction. Any decimal that terminates, we can write it as a fraction over its ending place value. There are also some other types of decimals that are in the rational family that don't terminate. Exactly, good. So repeating decimals. Repeating decimals. We said repeating 3. So 0.3 repeating. Prove this can be a fraction. Okay? 1/3. So we have another one that's pretty commonly used that can be a fraction. What is it? 0.6 repeating, which is what fraction? 2/3. Okay? 0.1 repeating is 1/9. 0.4 repeating is 4 ninths. Okay? Okay, so we get a rational encompasses all of these circles and more, includes our decimals. Now, there's something that's the opposite of rational. Irrational. That's where I comes in. Irrational are the nods. Irrational. So they are non-fractions. Can't say it as a fraction. They are non-terminating. Non-terminating decimals. And they are the two glasses. Non-repeating. So I'm going to explain all integers. Non-fractions, non-terminating, and non-repeating decimals. So in the Q box, we put some decimals that put outside of our circle to like 2.4. 1/3 because it was 0.3 repeating. 2.4 was 2 and 4 tenths. Over here in this thing by itself, so there's no overlap. You have both the fraction and non-fraction. There's no overlap. And so let's give an example of a very famous irrational number. Very famous irrational number. Pi. Yeah, 3.141592653. That's all I got. She's like, yeah, that's all I have. I only have like 10 digits. Every year I've memorized like 2 more, so by like 30th year teaching, I'll have a list. Okay. So, pi is an irrational number because it goes on forever and there's no pattern, right? They say 22 I think it's 22/7. Very close to the value of pi, but after so many digits, it finally diverges away from pi. So it's close, but it's not the actual exact value of pi. Another examples of irrational numbers. I know. Square root of 12. Anything with a square root that's not irrational. What? Why? Why is the square root of 25 not irrational? It's a perfect square. 25 is a perfect square. And the square root of 25 is plus and minus 5. Well, plus and minus 5 are integers. Okay, so some other ones. The irrational square root of 31, square root of 2, lots of the square roots that aren't perfect squares in the hand. Okay, well, all of these numbers are in what family? They're all real numbers. And that is located by the capital R with a slash. Real numbers. Well, you thought that was it. Today, the knowledge will expand the knowledge even more. If it's not real, it's going to be imaginary. Okay, so do you have any with that right now? Just another one, please. When it's quiet, I want you to think about why in the world am I showing you this and why is it applicable to what we're learning about. I haven't read it, so hold on, let me read it.
Democracy 18. Tell me anything here. This, the title. I'm looking at what that was. I've been in case working for 3 years. And that's right. I'm a stranger. Jay. No advice, no talking, hell no. No, I swear I'm fine. I'm coming over from Grand Central Germany. Why do you think rats in my locker, man? I thought it would give some perspective for you. No, it's actually kind of sad that we need to let it out of there. I mean, they need to know the world is bigger than that. So we're lucky.
Let's talk about why I would show you this. What just happened in those two clips? How did it start? What was the first clip about? A small world in the water. And Kay, Will Smith's boss man, he was kind of the keeper of the world, right? The leader. And then he took his watch, and she was like, oh no, I got you covered, here's my watch. So here's Will Smith, right? And then in the next scene, what happened? Who opened the world? No, not that part yet. At the beginning of the next scene, who opens a small locker? Jay, Will Smith opens the locker and man, why did you put those rats in my locker? Then what happened? What did Will Smith say? Hey, we have to let him go because we need to know the world is bigger than that. And he's like, that's cool. Right? If you can have that more, and you let him more than that. And what does Kay say? Still rookie. And I want as we're called them, the creature inside the little locker. I thought that's all that number is. But there's more. Will Smith's locker encompasses all that. But Will Smith doesn't know he himself is in a locker. And there's more. So you've become a locker today. Now, I'm still using one of the imaginary numbers already, but now we have imaginary numbers. We haven't briefly talked about them. There's been one that's I just put this on, we'll talk about it later, but just know it exists. And where do we get imaginary numbers? You remember? Negative square roots, exactly. Because the square root of 16, let's see. Here we go, switch to Alexia. Let's see, what's the square root of 16? You sure? There's two answers, right? 12 or minus 4. Potentially two answers. Okay, but the square root of negative 16 is a little more complicated because the definition of square root means a number times itself. So the reason square root of 16 has two answers is because two integers satisfy the root. Positive 4 times itself. Positive 4 is positive 4 is positive 16, correct? And negative 4 times itself. Negative 4 times negative 4, and negative times negative is a positive. So what number times itself is negative 16? So that would be negative 16, 4 times 4. So negative 4 times negative 4 is going to give us negative 16. No, we're going to do your calculator. Square root of negative 16. Make sure the calculator. I know there's one. What does it say? Error non-real, because the answer is it's not a real number, it's a what type of number? Imaginary. So then the answer is plus or minus 4 I. It's very similar, we just have to stick an I on the side. Okay, Stephen, what do you think the square root of negative 25 would be? Plus or minus 5I. Because if we're taking a negative square root, this is really like a negative 1 times the square root of 25. There are two things you need to know about imaginary numbers that you can memorize. Imaginary numbers. First of all, the square root of a negative 1 is I. And by squaring the I, it means I also have to square the square root. What does squaring the square root do? Takes away, because they're inverses. And by squaring the square root, what would be left? Negative 1. Hence why I squared's value is negative 1. These are two things that you need to memorize. Square root of negative 1 is I, and the value of I squared is actually a real number, negative 1. So there is a relationship between imaginaries and real numbers. I squared is actually a real number, negative 1. Okay? So, anyway, we must test what is the square root of negative 144. Can anyone tell me the answer, please? The square root of negative 144. Hey, Catherine, what'd you get? Great. Plus or minus 12I. Great. Okay, but the title of these notes was not imaginary numbers, it was complex numbers. We're going to do one quick thing on complex numbers, and then we'll continue with it next time. Complex numbers have two pieces. It's a real piece plus an imaginary piece. It looks in the form A plus BI, where A is a real piece, like a real number, because it doesn't have an I, and BI is an imaginary piece, which exactly has an I. So complex number could look like the number 5 plus 7I. I'm talking about plus a comma. 5 plus 7i. As a real piece, 5. And an imaginary piece, 7i. That's a complex number. We can actually even graph these. And very similar to graphing regular planes. You guys know how to graph by 7, right? Okay. How do we, Dottie, how do we graph by 7? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, right? And then I have right here the point 5, 7. Yeah? Well, graphing 5 plus 7i is very similar. We have the x-axis and the y-axis. Very similar, but their axes are different. The x-axis is your real axis. The y-axis is your imaginary axis. So the waves, just like ordered pairs, the real piece is your horizontal movement. So we're going to go on the real axis, A4 over 5. And then the imaginary piece is your vertical movement. So we're going to go up 7i. It's not just 7, it's up 7i. So it'll be right here. 5 plus 7i. But don't write it as 5 comma 7i. It has to be plus or minus in the middle. Okay, let's let us stop on these. We're going to continue with it next time. But what do you have to bring next time? Volume 2, please. So your homework was the quadratic regression from 3-3. You have 8 more problems on that. 1 through 3 can be done by hand. We already did number 1. And then from there on, you can use your calculator. Okay, please put your lid on your calculator and bring them up. Yeah? So we do it roughly?
So this one is 103, there is a sign up on there.
Yeah, the factory. You can put that on your footer. Yeah, you can put it on your footer. I'm just going to go over now so that I can get. Hey, don't forget, take work up to quadratic formulas today.
I did most of the I was wrong. So I got strengthened in a surgery memories. The ACT prep test for the sophomore, so they gave it for review.
This is the last one.
Yeah. I was down Friday and that was okay.
Yeah. And because of my applications,
I only have this is not in lead, but I did the rest of it. And like, so that is like one side.
okay, you just need to know what one of those 3 quadratic formula. So this looks like solving, we've got you turn that one in. And this, yeah, and then sit down this time. Okay, so 2 more to do on that one.
That one's the one that I do.
This is quadratic formula, it looks like. Okay, so put this one in your folder. You can turn this on.